Welcome to Industrial Electronic Devices. This video is Module 1, Introduction to Electronic Tools and Methods. This first video is on measuring devices, digital multimeters. Note, this presentation is an introduction to digital multimeters and only covers a limited number of aspects with respect to the selection, use, and care. It is not a comprehensive study of all facets of multimeter operation or use during an electrician's employment, and cannot cover all forms of misuse or abuse of any multimeter. It does not fully cover the proper safe use of a multimeter and use of proper PPE, arc flash, lockout tagout, and working with voltages higher than 30 volts AC/DC. This presentation does not endorse the use of any meter while live voltage or current is potentially available, and the care and use of your multimeter must follow all applicable safety regulations and legislation as covered in other portions of your education, your experience, and common sense. As electricians, we depend on several different measuring instruments, both for troubleshooting and verification. The workhorse of electricians is the multimeter. It's primarily used for voltage measurement, current measurement, and resistance. Depending on the manufacturer and the meter itself, some versions also measure diodes or transistors, continuity, temperature, and capacitance. Unfortunately, not all meters are created equal. Features are only one consideration of a digital multimeter. The quality and robustness are important too. But the real difference lies in the safety of the device. Of these three digital multimeters, only one is suitable for an electrician. Test meters are rated by the category of work you're expected to encounter. While some may technically get you by, using them could be risking life and limb and would not be following the Occupational Health and Safety Act. Assuming you are following lockout tagout and assuming you are using arc flash protection, before working with any digital multimeter, before you even plug in the leads or turn one on, you must follow the 5 ironclad rules of multimeter use. One rule for each finger on your hand you want to keep. Before we get too carried away with the differences between one model and another, we should discuss the ironclad rules of digital multimeter use. And the first ironclad rule of any digital multimeter is RTFM. Read the free manual. It could save your life. The second ironclad rule of any digital multimeter is RTFD. Read the function dial. The dial determines what the meter will read and the internal electronics to make that happen. The wrong setting can kill you. The third ironclad rule of any digital multimeter is RTFS. Read the function screen. It could save your life and save your meter and actually help you do your job. The fourth ironclad rule of any digital multimeter: inspect before you test. The fifth ironclad rule of any digital multimeter is, when in doubt, go find out. Don't ever be afraid to ask questions. Each time before you use any meter, if you use it incorrectly, a meter can be worse than a grenade in your hand. To avoid this, make the following safety habits from day one. First, RTFM. If the meter is not yours, but it looks the same as yours, don't assume you know how it works. Manufacturers make many varieties of meters, even with the same housing. Second thing is, make sure it's the right meter for the job. Do you have the correct meter for the job at hand? Multimeters are application specific. Number 3, inspect. Inspect your meter and its leads before you use it. Storage and care of your multimeter will ensure its operation for years to come, but even with the greatest of care, wear and tear will happen and leads may become damaged or give you false readings. A disconnected or open lead wire will tell you there's no voltage present. And while you're inspecting it, check the state of your battery. The 4th daily habit is to test live, dead, live. This is a method of checking meter functionality. To begin with, you use a safe low voltage known source, such as a fresh 9-volt battery, and check the correct meter function and verify the meter is working. Then, check the meter against a safe known dead source to verify it reads that correctly and the meter has responded to the change. And finally, double check again against the original safe known source. If the readings do not agree, or there is hesitation, you may need to replace the batteries in your meter and start again, or do not use or trust the meter. So what is the right meter for the job? Well, meters have ratings and categories. Meters can fail if the wrong meter is used. Meters have a voltage ratings on them, but the voltage ratings are not application ratings. Application ratings are called categories. It is imperative that the correct category of a meter be used for the correct application. There are 4 categories. Each category is designed for higher voltage protection and usage application. On the meter shown, there's no category found. What would you assume about this meter? Well, let's find out. To be clear, this is just an introductory guide to meter categories and the appropriate meter selection for the job. Always consult the manufacturer's free manual for clarification. These categories are based on the fault current and possible transient voltage spikes, etc. for each category. So let's begin by looking at Category 1. Category 1 is primarily intended for low voltage applications, such as checking end-use appliances or electronics and circuit boards. These tend to be inexpensive with lightly insulated leads. Think of them for a hobbyist, not an electrician. These belong at home. Do not bring them to the job site. The meter shown has no category. This should be considered Category 1 or a throwaway. When purchasing a meter, if you can't find a category, don't buy it. Your life is worth more than saving a couple of bucks. Pencil meters should only ever be considered Category 1. I mean, even if it says Category 2, still think of it as Category 1. Ask yourself this. That probe is really short. Do I want to stick my hands or fingers near 600 volts like it's rated? No. This unit again is for hobbyists working on their toy trains. Pencil meters, real electricians do not use them. Category 2. Category 2 is checking power on the load side of a single-phase service panel. That is, from the circuit breaker's circuit and downstream devices from that breaker. Notice that the line side of the panel wires are not included in Category 2. This means that Category 2 is also not suitable for checking the panel's circuit breaker bus or the incoming line. Think of Category 2 as a homeowner, not an electrician. When looking at a meter and checking its category, you have to use some common sense. This meter shown is rated a Category 2. Now the voltage and amperage ratings are laboratory tested, that is, in ideal brand new condition. Do not assume that this meter, for example, would be safe and 750 volts AC, given its age and condition. Category 3 is checking power on the load side of a three-phase service or the circuits and devices downstream of that panel. These tend to be made for industrial motor testings, etc., and a tougher environment. Category 4 is for checking power, etc., on the line side of a panel or for the load side of a utility incoming service. It's also used for outdoor lines and feeders. It is not intended to be checking high voltage. Let's use some common sense. Let's use an example, taking a look at a meter that says Category 3. So this meter has a Category 3 rating and a Category 4 rating. What? Oh yeah, it does. Well, how do you know which is correct or which application it's suitable for? Well, the first thing you can do is you can always assume the lower rating, or you could RTFM or UPAGI. Use your phone and Google it. This is a table that shows the different configurations of meters and shows the working maximum current and voltage and transient settings. Notice that the highest working voltage for any of the categories is 1000 volts. And the transient, that is a momentary spike, is only rated at 12,000 volts. If you expect anything more than that, you don't have the right meter. And all meters should have the category rating clearly marked, but the category must also be accompanied by the maximum voltage the device can withstand before failure. The unit shown is rated up to 600 volts, Category 3. However, this is not the complete picture. This meter can measure some current. To do this, the meter must be placed inside the circuit. The maximum fused amperage the unit can handle is different depending on the connection ports used. The left red port is designed to measure current up to 10 amps. The right red port can only measure up to half an amp or 500 milliamps. There's also another part of the category chain, perhaps the most important part of the chain. Since the leads are the parts you'll be handling, shouldn't they be categorized too? The black lead has a protective cover in place. The red one does not. With that protective sleeve removed, the test leads category drops from 3 down to 2. You've just gone from an electrician to a homeowner. Tester leads have category ratings as well. The category rating drops once you remove the tip sleeve. And while you're at it, check for the double D or double insulator rating symbol on the actual leads themselves. So we talked earlier about each time before you use any meter, and we got to step 3, inspect the condition of the meter itself. Absolutely. Things change. Things get dropped, broken, etc. So let's take a look at this particular picture. Check the lead ports for damage like this one. You can't put the lead in properly. You can see it is deformed. Check the case for damage, cracks, etc. Voltage ratings only apply to perfect case integrity. Then check the battery level once it's turned on. Continue by checking the leads. Check the plug sleeves for damage, check the condition of the tips. The set shown are garbage. Look for nicks, cuts, and signs of abrasion or abuse on the wires themselves. And use the tip sleeves. Do not lose them or throw them away. Here's a pro tip. Have a buddy at work? Occasionally use their meter to occasionally ring out your leads to see if there's continuity. When you've inspected them and you're ready to insert the leads, make sure you are inserting them into the appropriate port for the task at hand and for that particular meter. The black lead will go in the identified black port commonly referred to as common. Do it first. The red lead can go in two different ports. It can go in the volts, ohms, and milliamps port or the current testing port. The red volt, ohms, and milliamp port will be used the most. But keep in mind, the internal impedance changes depending on the function dial selection. One setting is safe, another may not be. Regardless of the milliamp reading, remember that some current readings taken will use the leads rather than the clamp-on function, DC for example. When this is done, the meter will be a part of the circuit being tested and live current will flow through it. The current 10 amp port is used whenever you need to test the current being drawn through a lightly loaded circuit. This feature only applies to non-clamp-on meters and puts the meter into the circuit like a fuse. Careful warning here. Since all the current readings will be taken with this meter and has the meter leads placed into the circuit being tested, never connect with power supplied, or you'll die. Simple as that. Selecting before testing. The setting you select changes the electrical properties of your meter, not just in the analysis of the circuit being used, but the way the meter appears to the circuit being tested. Some testers are fused internally, but these may have been defeated and are difficult and expensive to replace. Always double check. Alright, so let's take a look at the electrical properties by function dial setting. So the first setting is voltage. When testing voltage, the meter is placed in parallel with the circuit between 2 points. You do not want to have the meter appear as a low resistance load because most of the current will go through the meter, not the existing load. Therefore, when set to volts, the meter presents a very high impedance or alternating current resistance. While on the voltage setting, also be sure to check the type of voltage you are expecting, alternating current versus direct current, or as I like to say, the sine wave versus the D.M.M. Dead man on a gurney. You may get a reading of the other voltage when testing a circuit. There could be leakage DC on an AC circuit of a few millivolts. You may think the circuit is off, and then, boom, you're dead. There could also be an induced trickle AC voltage on a DC circuit. And again, you might think there's no voltage, and then, boom, you're dead. When measuring current, the meter is placed in series and presents a very low impedance for a very tiny voltage drop. Most meters have an internal fuse to protect the user from putting the meter across a voltage. However, if the fuse is defeated or the meter crowbars a high current source, the meter and leads turn into a high temperature copper plasma that plasters your face into a Joker-like smile you wear for the rest of your life. And that was as quoted by Paul McCartney, a retired electrical engineer. When measuring resistance, the meter outputs a small current and then measures the voltage drop created by the circuit and calculates the resistance present. The meter will start trying to calculate the voltage drop the moment the meter is turned on and resistance is selected. Air has a high resistance that is beyond the limits of your meter, and it will display OL for overload. Again, checking live voltage source while on ohms may result in serious injuries. And always, always, always double check. Double check and RTFS. Read the function screen. Read the function dial. You're getting paid by the hour, not by the job. It's not a race. It's certainly not a race you want to lose. Of the 3 meters that are shown, only one of them has the correct setup. Which one? The meter you are supplied with performs like most other digital multimeters, but has a non-invasive ammeter. The ammeter function on your meter uses the magnetic energy emanating from an AC circuit. It converts this energy into a signal and calculates the amount of current being drawn through the wire to produce that magnetic field. To obtain a current reading, the clamp opens up and allows the electrician to surround the wire to be tested, and then, when safe to do so, re-energize the circuit and take a reading. Your meter also comes with a K-type thermocouple and adapter. This allows you to take simple temperature readings. Want to know how? RTFM. Another device that you may see or run into in your trade is something called a wiggy. Wiggies are portable voltmeters. They operate on an internal solenoid that will close proportionally to the application of voltage. They are rugged, and some have continuity testing as well. Unfortunately, being rugged also means being abused, and the leads, etc., can get damaged. Some older versions were recalled, so be aware. Well, we've covered quite a bit in this little exploration into the introduction of digital multimeters, but let's keep the following in mind. A digital multimeter is an electrician's workhorse for troubleshooting and circuit testing and analysis. Used correctly, it will provide accurate information and for years to come. Again, this presentation cannot and does not cover every type or model of electrical D.M.M tester, nor does it cover every aspect of meter use or abuse. It's just an introductory guide. And when in doubt, RTFM, RTFD, RTFS. And do not be afraid or embarrassed to ask someone for knowledgeable help. In your career as an electrician, you will be required to take measurements as a part of troubleshooting and to effect repairs on different electrical installations. Knowing how to use these devices safely and practically is an important part of your education. Multimeters can measure voltage, resistance, continuity, and to a lesser extent, current. If used incorrectly, they can pose a serious health and safety risk. Care and safe upkeep of these devices will keep you and others safe, and they'll perform well for years. Up next, we're going to look at analog meters.